Go to the page 166. The topic is connect representations of functions. In the example 1, we need to represent a linear function with an equation and a graph. So I'm going to write the facts we have about each part of the exercise. A 10,000 gallon swimming pool needs to be emptied. Exactly 2,000 gallons have already been pumped out of the pool and into the tanker. How can you determine how long it will take to pump all the water into the tanker? Okay, so inside the pool you can have 10,000 gallons of water. You have a machine that is going to empty the pool, is going to help you to empty the pool, and it has a constant speed of 720 gallons per hour. So you know that you have a constant rate. When you have a constant rate, what is going to represent this in my function? It's going to represent the slope, because you have the same slope in each point of the graph. You have 2,000 gallons of water inside the tank, 2,000 gallons already on the tank. So this is the number of gallons you already have, the number of gallons already pumped. So this is the initial value. And the initial value, where my graph starts, is going to represent what? It's going to represent the y-intercept, okay? I'm relating the facts that I have with the parts of the graph, because I need to write the function, okay? So one way to solve this, you can see in the part below. One way is to use the information given to draw a diagram that represents the situation, and then we can write an equation. Okay, you know that we use diagrams in this kind of example to understand better what is happening or to understand the situation. In this case, we need to use the information we have about the water, the pool, the tank, etc. The 720 gallons per hour. So look at the diagram. The total amount of water to be pumped, it's 10,000, right? 10,000 gallons. This is the total you need. So the total of the water, what is going to represent y. Okay, this is all the water you have is y. So I have 10,000. Now, what is the slope in this case? The amount of water pumped every hour is the constant rate of change you are taking. Okay, you are pumping out 720 gallons each hour, so it's a constant rate. Each hour you are going to take the same amount of water. So the constant rate of change is going to be the slope. So the slope m is going to be 720. And in the other part, what we have? The amount of water already pumped is the initial value, or the y-intercept. So the y-intercept, I'm going to write it in here. The y-intercept is 2,000. Okay, you don't have to worry about this kind of examples. If you, as you can see, guys, we are only taking the values they give us and replacing this on the equation. What equation do you have? You need to remember about this equation, y equal mx plus b. This is the kind of equations we were working with. So we need to replace the values we already have in this function. What is the value of y? 10,000. This is the total, okay? The total of the water. M is 720 multiplied by x. We don't know x. X is the number of hours. The number of hours, we don't know it, okay? Even is the number they are asking you to find. plus b. B is going to be 2000. This is the initial value. This is the y-intercept. The point where my graph touches the y-axis. The point where my graph starts. This is the y-axis. And what other thing do we have in here? We have the equation. They ask the number of hours. This is the equation. You can find the number of hours. Only isolating the variable. This number that is in addition, you pass it to the other side to subtract. And the 720 that is multiplying my variable, you can pass it to the other side to divide. If you can see on the book, they don't find the value for x. They only write in here like this. But we can find the number of hours. You don't have any problem finding the number of hours because you already learned how to do it in the last chapter of the book, okay? So solving the equations. So I have 10,000 minus 2,000 because you pass to the other side to subtract this number. This is going to be equal 720x. And what is going to happen with 720? It's multiplying my variable, so I'm going to pass it to the other side to divide. Don't forget about this. Your entire life you are going to use this if you study something related with math. Or even if you choose any other career, you are going to need this. So at this part, we have to divide this. I'm going to place the line in here. I'm going to write the line in here. So you can see it as a fraction, okay? So what is the value for x? Can you find the value for x? When you subtract 10,000 minus 2,000, you have 8,000. This is divided by 720. And this is going to be equal the value of x. So what is the value of x I have? X is going to be what? When you divide 8,000 by 720, it's 11.11, right? So about 11 hours. To round, okay? To round about 11 hours, but you can have it like this, 11 hours, and I think that we can use this as 0.11 of an hour, 0.11. They are as at least 6 minutes, 6 more minutes. Okay, but we don't need this. It could be 11 hours and 6 minutes with this part. But we already have the answer. It's going to take about 11 hours to completely take the water, to pump the water out, okay? To pump all the water into the tanker. About 11 hours to pump all of the water into the tanker. Okay, and you can see the graph. You have it at the right part. This is not much in this exercise, guys. You have the graph. You start the graph when in what part? In the y-intercept. So you locate 2,000 on the y-axis. The slope is going to be 720. So about the graph, you don't need so much. It's a straight line. Remember, it's a straight line because it has the form, this form of the equation. It is a straight line. Doesn't start at the origin, 0, 0. Starting this point. And, okay, you have everything in this case. We already have the equation. So, we can go to the example 2 if you want. On the example 2, we need to represent a non-linear function with a graph. How can you determine whether the relationship between side length and area is a function, and what you have in this example? I have this. I'm going to draw in here. And what you have inside is that the area is equal S to the square. I don't remember where is the, okay, this, I found it, to write the power of 2. And what is going to happen with the other one? This side has a value of S, and this other side has a value of S. Now, how can we use this then? I'm going to move this. How can we use these values? We are going to copy the table we have in here, the values for X and the values for Y. In X, we have 0, 1, 1, 2, 3, and finishing 5. In Y, you can see what is the value of Y is this number to the power of 2, because the formula for the area in this case is to multiply the side by itself. Remember, this is the formula of the area, okay, the area of the square. So X is the length of each side. For example, when you have length is 0, the area is going to be 0 because you multiply 0 times 0. When it's 1, it's going to be 1 because you multiply 1 times 1. When it's 2, the area is going to be 4 because you multiply 2 times 2. When the side is 3, the area is going to be 9, 16, and 25, okay? Because it's the power of 2. Because this number is to the square. Now, what do we need in here? I'm going to draw the line. What else we need to do in this example, guys? We need to complete to find the functions. We need to identify if this is a function or not. Is this going to be a function? Yes, because for each value of X, you only have one value of Y. For this, you have this one. For 2, you have 4. So for each value of X, you have only one value of Y. So yes, this is a function. And you need to graph the ordered pairs from the table. So maybe if we graph the ordered pairs from the table, I'm going to draw this in here. I have this, and I have this one in here. Okay, and I'm going to draw the other one, starting here. Okay, then I'm going to place all the points. You already know how to place the points, guys. You start, for example, when this is the origin, X is 0, so I'm going to write the values for X. I'm going to write the text in here. The value we start is 1, 2, 3, 4. I'm going to give more space. This is what we have, right? And for Y, we can have more space if you want, so you can see it better. I'm going to erase this and I'm going to give you more space so you can see it better. 1, 2, 3, 4. To cover all this space, okay? This is better. This for the equation is better. And then I need to do the same with the values of Y. With the values of Y, I'm going to insert this only that it's vertical. 20, 15, 10, and 5. We start the graph. Look that maybe for 20, we don't have the space enough. It's going to be out of the graph, but until 15, we can represent the functions. I'm going to do the function, but maybe it's not going to be perfect. The function you have, when x is 1, you have 1 for y. The point is going to be placed like in here, for example. In here, I need to draw. I'm going to draw the line first, and later you can see the points. I forget to write this. It's something like this, right? Okay, maybe it's not going to be perfect, but I'm trying to do a curved line. It's not a straight line, it's curved, okay? And you mark the points when, for example, x is 2, it's going to be 4, it's not going to be 5. So you place the point like in here. For when it's 3, it's in here. So you can see that we are only trying to represent this. The important part, guys, is that you write all the points, okay? You place the points and you draw the line, and you are going to see that it's not a straight line. This is the important thing here, only that. Okay, maybe it's not going to be perfect, I repeat, because I don't have the grid lines, and you already know how to place the points, and you know how to do it on your book, and you know how to do it when you are using one application, for example, GeoGebra, okay? So you take the origin 0, 0. This is the origin, right? You take when x is 1 and y is 1. It's going to be like in here. I don't have the exact place because remember I don't have the grid. When it's 2, when x is 2, y is going to be 4. So you write the points, okay? Remember I don't have the grid, so the points are maybe sometimes above and sometimes below. This is a function, but it's not a straight line. It's not then a linear function. In the example 3 we finished, we only need to identify the functions. We need to identify the functions watching at the graph. For example, determine whether each graph represents a function. The first one and the second one are functions because only you have only one value of y for each value of x, right? So each represents a function, x value, each value of x corresponds to exactly one value of y. In the other one, in the last one, this graph doesn't represent a function because x values doesn't correspond to exactly one y values. There are two values of y for each value of x. So -2 corresponds to 2 y values. I'm going to draw in here. Maybe you can see it better. We finish with this. You have something like this, right? And you have the graph. Okay, I need more in here. I'm going to draw in here and a little bit for the other side. So when you draw the line, I'm going to try to draw the line. You have a curve in here. You have something like this. And the point is that for each value of x, you are going to have more than one value of y. For example, you can see that they mark 2 points. When x is -2, you have 2 different values of y. X is -2 in here, for example. And you have two different values of Y. You can see that you are going to cut in here. And if you continue extended one, okay, I'm going to draw the line maybe in here you can understand. Imagine that this is -2. This is -2, this point. And you pass a line. I'm going to move the line because it's not going to pass exactly by the 2 points. Can you see in here? You pass the point and you are going to cut the graph in two different parts, in two different points. So you have two different values of Y in here and in here. This is the idea of this, that for each value of X, you have more than one value of Y. The same in here, for example. Can you see it? You have one value of X. For example, this could be +3, I don't know, +4. And you have two values of Y. Look, the first value in here, and the other value is going to be in here. This is the idea of this. It's not a function because you have more than one value of Y assigned to one value of X. So I'm going to finish the class in here, guys, because we don't have much time already. You have the homework to complete the other pages. They are located on the page 168, 169, and 170. This is the homework you are going to solve. 167, 69, sorry, 68, and 170. So see you guys. Have a nice day.